All right, Honors Chem. Sorry about my computer. It is having a hard time keeping up. So we're going to do our last example of using an ice or a rice chart. So example 8, here we are on the bottom of page 218 in your workbook. Okay, so calculate the pH, the pOH, the hydrogen ion concentration, and the hydroxide ion concentration. Remember, those square brackets mean mole per liter, molar concentration, in a 0.100 moles per liter benzoic acid solution, where the acid constant is 6.5 times 10 to the negative fifth. Okay, first things first, we're going to create that ice or that rice chart. So we're going to start with the reaction on top. Okay, so we're going to start with our benzoic acid. Let's see, HC6H5CO2. And that is going to go back and mostly backwards, but a little bit forwards to our hydrogen ion. And then we will have benzoate. Or nope, that's a 2. Okay, so there is our R line. Next, we need to create the I line. Remember, the I is our initial concentration. So our initial concentration is 0.1 molar benzoic acid. Okay, we're going to pretend that we start with no hydrogen and no benzoate. Okay, next we're going to have our change line. Now notice in our reaction we have a 1:1:1 ratio here. So every benzoic acid molecule that ionizes, we're going to lose some. So this is going to go negative, right? Negative X. We don't know how much, but negative. For every one of those that we lose that ionizes, we create one hydrogen. And we also create one benzoate ion. Okay, so we have a 1:1:1 ratio there. Okay, now our equilibrium line is the sum of our initial concentration and our change in concentration line. So 0.1 plus a negative X is really 0.100 minus X. 0 plus X is X, and 0 plus X is X. Okay? The next thing that we've got to do is we've got to create our equilibrium constant expression. Remember, products go on top, reactants go on the bottom. Okay, so our equilibrium constant for this acid is going to be equal to my concentration of hydrogen multiplied by my concentration of benzoate, all over my concentration of benzoic acid. Okay, now I can start plugging things in. Okay, and I'm going to plug things in like so. Okay, hydrogen, X, is going to go right there. And that should have changed color. Okay, benzoate right there, going to go there. Benzoic acid is going to go there. And my constant, going to go here. Okay, so we're going to plug those things in and let's get going. Okay, so here we go. My Ka, 6, oh boy, that really took a while to change. All right, 6.5 times 10 to the negative 5 is going to be equal to X times X, which is X squared, all over 0.100 minus X. Now, as I said before, this is smaller than 10 to the negative 3. So that means I can ignore this X. Okay, so I'm going to ignore that X. So it's really going to be 0.100 because I can ignore it. Okay, so I'm going to take 0.1 times 6.5 times 10 to the negative 5. So that's going to give me 6.5 times 10 to the negative 6. So 6.5 times 10 to the negative 6 is equal to x squared. Okay, so I just need to take the square root of that. So here we go. Square root of 6.5 times 10 to the negative 6. Close my parentheses. That gives me 2.5 times 10 to the negative 3. So x is going to be 2.5 times 10 to the negative 3. Now I can only report 2 digits. My calculator really gives me 2.5495098 times 10 to the negative 3, but I only have 2 digits here, so I can only do two digits here. Okay, so that is what x is. So I have 2.5 times 10 to the negative 3 here, and 2.5 times 10 to the negative 3. And that gives me, let's see, 0.1 minus that. Oops. Let's try that again. 0.1 minus second answer. That gives me 0.0, let's see. I really can only go to the thousandth place. So 0.97 is where I'm going to round that. Okay, so I've got my concentrations now at the equilibrium. Now let's see what I'm actually asked to find. So I'm asked to find the hydrogen ion, which is what we've got right here. So there's my hydrogen ion concentration. That one's done. Okay, the next thing is probably to find my pH. So if I take the negative log of the hydrogen ion concentration, that will give me my pH. Okay, so I'm going to do the negative log of that. So negative log, and let's see. Oh boy, I cleared stuff and I shouldn't have. So let's start over. 6.5. I'm going to take the square root of that again. 6.5 times 10 to the negative 6. Okay, I'm going to take the negative log of that now. So glad that there's answer buttons here so that I can just cut and paste things. So that gives me a pH to the hundredths of 2.59. Okay, so there's the pH. Then the next easiest one probably to grab is the pOH. So if I take 14 and I subtract that, I get a pOH of 11.41. So that's done. And then finding the hydroxide ion concentration, I'm just going to take 10 to the negative pOH. So 10 caret key negative answer. That gives me, let's see, really 2 sig figs, 3.9 times 10 to the negative 12. Okay, so 3.9 times 10 to the negative 12 will give me my pOH. So I've been able to find all of that data right there, and just from figuring out the ice chart or the rice chart, whichever one you want to call it, and using some algebra. Now, hopefully these rice or ice charts, whatever you want to call them, give you an idea of why the quadratic formula was actually invented. For stuff like this is why the quadratic formula was actually derived. So hopefully this is making sense to you. If it's not, please come and talk to me, email me, or we can get you some help at school. We'll see you later. Have a great night. We'll see you. Bye.